Hello guys, so in this video we will talk about generator function in Python. So till now we have covered the topics like iterator, iterable, what is the difference and all related topics. So in this video we will talk about what is generator function and what is the need of that and what is the benefit of that. So without wasting time, I'm sharing my screen. So right you can see this is a Jupyter notebook. So if you have seen my earlier video which was about list and tuple comprehension. So I'll give you an example of tuple comprehension to begin with generator function. Okay. So if I write something like this, I for I in range of 10. So it is an example of tuple comprehension. If you want to know the details, you can watch my earlier video about tuple comprehension. If I do that, you can see instead of printing the numbers from 0 to 9, it is giving the output as generator object is created and some random. It looks like garbage value, but it is not a garbage value. It has created a generator sequence from 0 to 9. If you want to print that, you can do something like this. I'll try this. If it doesn't work, if we can put it in a for loop. And if I write something like this, print j, let's see it work or not. It works. Okay. So basically it generated the sequence of numbers from 0 to 9. But without this print function, it is not printing anything. Or if I pass this value as it is in a print function, it is not show me anything. It will show me something like this generator object. So we will talk about this in this video. So why it is and what is the need of that. So instead of this tuple comprehension, if I write the same code, but in list, that is a list comprehension, I for I in range of 10, exactly same code, but inside a list. Instead of this round bracket, I have used the square bracket. It is an example of list comprehension. It is also, I have also explained this in my earlier video, that is list comprehension. If I do that, you can see I got all the numbers as it is from 0 to 9. This time I didn't get any warning or any message, something which is shown highlighted over here. So what is the difference? So in both the cases, I am creating a sequence of numbers from 0 to 9. But in one case, all the numbers are created and put it into a list and then shown in on the console in this example. But in earlier one, it is shown as a generator object. When we are creating a sequence up to 10,000, maybe lakh, it is fine, no issue. But let's assume you want to create a sequence of numbers which is very, very large, maybe thousands and lakhs and crores, like 10 crores, more than that, very large number. If you try to do that in a list comprehension, it will take much larger time. For an example, if I run this, you can see it is running for a very short amount of time. But if I copy this code as it is and put it here, and instead of 10, I'm trying to generate a list of numbers starting from 0 till these many numbers. Okay, it is a very large number. So I'm writing something like this for now. If I do that, you can see, you can look at this star. It is taking comparatively more time than the earlier case. Okay, I'm running it once again. You can see it is taking more time. If I still make it a bigger number, you can see it is taking much longer time, and that's the thing. That's where the generator function comes into the picture, because generator function takes less time and less memory. Before my system gets stuck, I'll interrupt this to save the time. Otherwise my system might get hanged, because it will use all the memory in my RAM, because it is trying to generate so many numbers from 0, 1, 2, 3 till this one. Okay, so if it comes out of memory, it will hang my system. But from the example you got to know that if I try to run this command, it will take long time. Okay, so but instead of that, if I do this with tuple comprehension, and we know in tuple comprehension, instead of creating a long list, it will create a generator object. If I do this, you can see it didn't take any time at all. It was just a fraction. It took just a fraction of a second and it generated the list. So one thing is clear, that generator function will take less time, and at the same time it will take less memory also in your RAM. How? I'll explain that. Whenever you try to create a list, what it does, list or tuple also, what it does, it will take one number, put it into a list, then another number, third number, fourth number, fifth number, all the number, whatever you put in your logic, it will put all the numbers in that list. And once the list is created, then and then only you can print it, you can put it on a console, or whatever operation you need to perform, you can do that. Okay. But when we talk about the generator function, the beauty of that is it will not create the whole list at a time. Okay. What it does, instead of storing all the values, all the numbers, it will store the logic or rule to generate those numbers, and it will store that. So right now in this generator object, all the values are not stored. It only stores the logic required to create those range or create those sequence of numbers. Okay, so that is the difference. Why it is needed? Just like this example, if you want to create a long sequence or large sequence, then to do the task and at the same time you want to reduce the consumption of memory and time, you can use generator object instead of list or tuple or some similar data types. Now the question comes, how we can create our own generator object. Okay, how to create a function which will create a generator object instead of returning a single value. Whenever you write a generator function, it will not return a single value or double value, something like that. Instead it will return sequence of numbers, that it will return a what I'll say, iterable object, iterator object, with the logic to create all that sequence. So I'll show you, I'll give you an example. Let's create a def. I'll write a function. First I'm using a list, that is nothing but a def sq square list. Okay, I'll pass n. What I'll say, for I in range of n. Okay, I'll say print n square. Now what our function will do, whatever number you will pass, it will print all the square of all the numbers starting with 0 till that number. I'll show you. If I run this code and if I call this function square list, if I pass value 10, you can, okay, instead of n I should write I here, that is a mistake. So I'll write something like this. So you can see from 0 to 9, for each number it created it squared that number and printed it one by one, and it didn't take much time. So print function will also work, right? Because it is also not storing all the values in one list and then printing it. So in this way also you can save time and memory, you'll say. But there is a problem. This function is working as expected, but what if I want to use this output I squared numbers, and I want to use it for further processing? So let's say I want to use this number, I will store it in x, and if I try this, it printed it as it is. But if I check the value of x, you can see I'll print x. X doesn't store anything. Why? Because print function is used just to print it on a console. It will not store it in any of memory. Okay. So the second option is return. If you use return, what will happen? It will return just first number and it will exit the function, right? Because you can use return only once in a function. Once return statement is executed, you get out of that function. Okay, so instead of returning one number, what you have to make some changes. That is nothing but you have to create a variable, that is out. It is a list. Then what I'll do out dot append I square, and then I'll return out. Okay, so if I use this, and if I pass the value 10, out dot append. Okay, my mistake. Return should be outside the for loop. Okay, if I do this, you can see I got the same output. But again, the problem is here it is a small series from 0 to 10, then it is fine. But what it is doing, it is storing this value 0, then 1, then 4, 9, 16, 25, and so on. Once all the numbers are put into the list, then and then only it is printing that list. So it will take more time and more memory. Instead of that, I want to instead of creating a list, I want to create a generator object. Then the syntax will be a little bit different. So syntax will be like, instead of return, I'll use yield keyword. Okay. So for that, I'll create a new function, def square list. I'll write fast because generator function is faster. I'll pass some value n. Same for I in range of n. What I'll say, yield I square. If I do this, if I call this, you can see if I pass 10, it created a generator object. Now we want to check what all values are there in this generator object. So I'll write y equal to this, and I'll try to print y. So it is a generator object. You can't print generator object as it is. So if you want to print it, what you can write? You can write for I in y, print I, right? You got same output. So in this way, using this yield keyword, you can use the same function, almost similar logic, but to create a generator object instead of creating a list. Okay. Now, generally in every function, you can use return keyword only once. Once the return function keyword is executed, the whatever is written below that within that function will not get executed. You know that, you are aware of that, right? But you can use it multiple times. I'll give you an example. I'll write def my fun, just a random name for function, and what I'll write, yield 1, then yield 2, then yield 3, and so on. For now, I'll write yield 3 times. And if I write z equal to my fun, okay, so z is nothing but a generator now, generator object. And if you want to check the values in z, the one way is for I in z and print I, something like that. And another way is there, you can use next function, because whatever is the output of generator function, it is always iterator. It is a iterator object. Okay. So what you can do next of z, if you do that, you will get all the values one by one till that generator sequence ends. 1, right? If I run it once again, 2, if I run it once again, 3, if I run it once again, it will say stop iteration. Why? Because our generator from sequence ends there. Similarly, you can use yield and return statement in the same function. You can do that. I'll show you how. But I'll copy the same function. Here I'll write return something. I'll write just return 0, nothing else. And then I'll write again yield 4, yield 5. And let's see what happens. I'll write one more thing. I'll write yield 4 here, and then yield 5 and yield 6. Okay, that is the function. And z equal to my fun. I'm just calling this function. Okay. And if I do this, if I do next of z, running it for first time 1, then second time 2, then third time 3, then fourth time 4, then it stopped. Why? Once a return statement is executed in any of the function, then whatever is written below that will not get executed. It will just simply exit that function. So that rule is as it is over here. So in this way, I told you how you can use the generator function. Okay, what is the use of that? What is the syntax for that? Whether you can use return and yield at the same time. Okay, how you can use yield multiple times, but return can be used only once. Like you can write return multiple times, that there is no problem in writing that syntactically. But once any of the return statement is executed, whatever is written after that will not work simply. Okay, so this is how it is. So main some of the keywords I'll just recall, like revise that. Generator function will return a iterator object. Okay, it will return a sequence of numbers. Okay, generator object will store the logic or rule to generate that sequence. It will not store all the values. So in this way, it will save time and space. Space means memory on your computer to run that. Your code will be faster. So as per your requirement, you should use generator object instead of list or tuple. Okay, so your code will be more optimized. So that's it, guys. uh, that was all about generator function. If you have any doubt or anything related to this topic or Python topic, you can put it into comment box. If you like it, if you got some idea from this video, you can do anything to encourage me. You can do like, comment, share, subscribe. You can do anything possible to encourage me. This is Akshay Daga signing off. Thank you. Bye bye.